Welcome back to the hyperbolic coding chamber. Today we find ourselves in the coliseum of algorithms, fighting against not the LC developers, not LeetCode LLC, not even the delineations of difficulty between hard, medium, and easy, but really in the coliseum against ourselves. And also, maybe the audience is our past selves. Maybe this is really meta. This would actually be kind of a good show or a movie. But that being said, I received a great quote from a good friend of mine, the Control-C Ninja, legendary algorist, part-time developer, as well as professional computer toucher, who said that part of discipline is honoring your future self. And these are just great words. True in general. There's nothing to say, but it's true. All of it. So, yeah, I think that's just had me reflecting a little bit because I think it's hard to be kind to ourselves. I mean, I don't think anyone is a stranger to that effect. It seems much easier to be kind to others in some way. It reminds me of reading, I think I was reading a meditation book, or maybe it was a reflection about a meditation book. I don't remember, but I remember there was a passage on something about how this person who had been practicing loving kindness meditation, which is really a meditation about showing care to others, and mostly not focusing on others completely, but pretty much like it's called loving and kindness. And it had a really strange effect in the sense that this person had been practicing this meditation, and by practicing to be loving and kind to other people in a very, very strange and meta way, they started taking care of themselves. And so maybe it's kind of strange in the sense that we see other people as strangers, but by maybe we see our future self as well as a stranger, and by practicing loving others actively, we find a way to love our future selves, which in a really, really meta way is a way to say, I guess we don't necessarily personify our future selves as ourself. It's just in a weird way. I mean, there's tons of documentation about this. I remember even in another book, I guess tying it in, they mentioned that there were hot and cold sensations. Cold being something or someone who is logical, cold, calculating ones and zeros. Hot being something emotional, desire driven, and just pretty much hot, right? You feel like you have to do it. And I forgot where I was going with that. That's just to say that basically it's hard to see our future selves as a real person, and part of doing that is being able to turn hot situations into cold ones. And yeah, it's just very interesting. So all of that has kind of been on the forebrain as I'm reflecting on the LeetCode journey and other things we'd like to accomplish. It's just making me reflect. So that's just kind of the stuff that I've been thinking about, and I'm kind of realizing that I think to achieve the other things I want to achieve, I sometimes forget that the battle is really between me and myself. So it's very strange. The game dev thing is going well, but I'm also noticing that I feel separately about the game dev thing than I do the LeetCode thing. And it's just very interesting. I think there's a part where game dev is in my brain that makes it a bit of a touchy subject. For some reason, there's part of my identity tied into it, whereas I don't really feel my identity tied to LeetCode at all. So it's just an interesting thing. All that to say, things continue on, things will be created, and the battle continues. Hopefully, each failure we make will help us put the puzzle pieces together to make something that, in retrospect, will be quite beautiful. But what we don't have to guess as to what will be beautiful is with the YouTube comments. So we have a legendary comment as per usual. Wait, give me uno segundo. Boom. We have a legendary comment as per usual by the screen is literally not updating. and I'm not exactly certain why. Okay, for some reason the setup is challenging us today. I'm not exactly certain why, but we have it back once again. We have a legendary comment from ADC, professional skateboarder, was a great mentor of the great Tony Hawk, showed him how to move, showed him how to skate, showed him how to kick flip. Gotta start posting those TikTok videos with Family Guy in the top half and the game in the bottom half. True. This is true. Okay, there is a war on our brains. But honestly, the thing is, it's kind of a cheat code though. I saw this one TikTok, or YouTube Reel, or Reel Short, it's all the same. And it was literally 4 panels. The top panel was like some kind of ASMR person with like floral foam. The other one was a person doing like a GTA stunt, like RP thing. And the bottom half was something else, but they're pretty much just 4 panels. And I was like, bro, we've gone too far. You can now get 4x the anticipation all at one time. There's not a moment where you have to sit. So this might be the cheat code. Maybe we'll just post 4 LC videos at the same time, or maybe I'll post myself like this, like doing one of these, like pointing up, and then there'll be 2 more panels. I don't even know. It's getting crazy though. It's a crazy time to be alive, man. But maybe it do be like that though. It's so funny because it's true though. That being the case, our last legendary comment, our previous video was called activating the God brain, and the God brain is approaching. We are cooking these problems, and I got a little sidetracked on one problem, spent a little bit too much time. Besides the point, we're finna fry these problems and continue the journey. So, oh, okay, now the whole tab switching thing is working. So yeah, we're just gonna continue through. I'm not gonna try and spend too much problem on certain problems, just because I typically will like find a problem, we'll spend an hour working on it, and then I'll find a problem, we get a good enough solution like brute force, and it's an easy problem, so the time complexity allowed is very ranging, which is fine. But then the other issue is that I'm optimizing a problem which we already haven't learned a ton from. So hopefully we're gonna try and reduce that. If we get a brute force solution or it's good enough, we're just gonna move on, with the intention being that hopefully the future problems will give us more difficulty. So yes, that being the case, we're jumping in. If this is something that interests you, make sure to join the Hyperbolic Coding Chamber, because the HCC needs you. We are recruiting heavily. We have hundreds of millions of thousands of people joining the Discord every hour, and we are commandeering resources across the globe to help us get there. That being the case, I hope you join us, and we're going to jump into the LeetCode. So, where were we? I'm pretty sure we haven't solved decode XOR array. I think this is where we stopped. So yeah, there's a hidden integer array R that consists of n. There's a hidden integer R that consists of, I'm just gonna make sure that this is actually indeed updating. Okay, it is. There's a hidden integer array R. There's a hidden integer array R that consists of n non-negative integers, which means 0 is included. It was encoded into another integer array encoded of length n minus 1. There's a hidden integer array R that consists of n non-negative integers. There's a hidden integer array R that consists of n non-negative integers, meaning non-positive, including 0. It was encoded into another integer array encoded of length n minus 1, such that encoded sub I is equal to R sub I XOR R sub I plus 1. For example, if R equals 1, 0, 2, 1, then encoded equals 1, 2, and 3. You are given the encoded array. You're also given an integer first, that is the first element of R, i.e. R sub 0. Return the original array R. It can be proved that the answer exists and is unique. Okay, so it was encoded into another integer array of length n-1. Right, given to us as encoded. The reason we have n-1 is because they're giving us the first value. But it's encoded such that encoded sub I is equal to R sub I XOR R sub I plus 1. You're given the encoded array. You are given the encoded array. You are also given an integer first. You are given the encoded array. You are given the encoded array. You're also given an integer first. You are given the encoded array. You are also given an integer first. That is the first element of R, i.e. R sub 0, which means the elements in the encoded array, which means encoded sub 0 is actually R sub, which means that R sub encoded sub I is actually I minus 1 in R. Return the original array R. So get the first example. Encoded equals 1, 2, 3, and the first number is 1. Right? The original array is this. So if we do 1 XOR 0, we get 1. 1 XOR 2, which would have 2 different bits, so we pretty much save them both. No, wait. Right, 1 XOR 0, right, gives you 1. Wait, wouldn't 1 XOR 0? 1 XOR 0 gives you 1. Oh, we're not carrying the values. Right, so we're not carrying the values. 0 XOR 2 is equal to 2. 2 XOR 1 is equal to 3. So we're pretty much given the final value and the first element in. We're given the final value in the first element of R sub 0. Okay. So how can we derive the value of encoded, which is 1, 2, 3? Oh, how can we derive the original? How can we derive the seed from the output? Basically, how can we derive the output from the input, given the output and the first value of the input? So maybe there's some kind of reversal operation we can do. We're given the first element, which is 1. And we know that 1 XOR something should give you 1. Basically, 1 XOR something gives you 1. 0 XOR something gives you 2. 2 XOR something gives you 1. That would give you 3 different values: 0, 2, and 1. And you add 1 to the beginning. This problem is a little bit confusing. So 1 XOR output is equal to 1, 0, 2, 1. First equals 1, right? Then we have 1 XOR something gives you 0. Then we have 0 XOR something gives you 2. Then we have 2 XOR something gives you 1. And then you have 1, 0, 2, 1 as the output. And I actually did this wrong. It's 1 XOR something equals 1. 0 XOR something equals 2. 2 XOR something gives you 3. So 2 XOR something gives you 3. And then encoded equals 1, 2, 3. Yeah, so encoded is the last 3 answers, excluding the first one because we're given the So encoded equals 1, 2, and 3. We're giving the first one, so we can do 1 XOR 1 gives you 1, which is part of encoded, which is here. I feel like I need to see the problem spatially. And then we have 1, which is part of first here. Output is equal to 1, 0, 2, 1. One XOR 1, question mark, XOR question mark. First equals 1. Something is very confusing about this. First of 1 is also the R sub 1. And encoded is the what we're given. We want to get to the output, which is really the input. So we do have sort of a cascading thing though, because if we have 1, which is the first value, XOR is not 1. We're given the first value, which is 1. Now we know that 1 XOR something equals 1. If we figure this out, we know that 1 XOR something equals 2. If we figure this out, we know that 2 XOR something. So we do have these other parts. No, I keep forgetting it's not carryover. It's not carry. I keep carrying it over. That's why it keeps getting confusing. I always feel like I run into a transference issue where I'm trying to see this problem as another problem. It's not that problem. It's a different problem. We have a question mark here because 1 XOR something does equal 1, right? And a thing that goes here would actually be R plus . I think it might be easier to understand if I just remove this or if I separate it out, because I think I'm getting confused. We start with 1. You know that 1 XOR some value, which is R plus 1, R sub I plus 1 equals 1. We don't know what this number here is. then first equals 1 encoded equals 1 XOR 0, and then 0 XOR 2. Coded sub I is equal to R sub I XOR R sub I plus 1. Maybe this is a better way to see it. We create some space between all these characters. Not a big fan that it always adds a period. So 1 XOR 0. 1 XOR 0, just a 1. 0 XOR 2 gives you 2, and 2 XOR 1 gives you 3. Now the thing that we don't know is this. So 1 XOR something gives you 1. Once you figure that out, 2 XOR something gives you 2. Once you figure that out, that value XOR something gives you 3. So if you know that 1 XOR what value would give you 1? Have to be 0. This would give you 0. Right now, 0 XOR what gives you 2. Would be 1. So I think we can template a solution to this. Maybe it looks like seems like we can just iterate for every element in encoded.length and just do output.push the math.absolute value of the most recent element in output, right, subtracted by encoded sub I. One five. Maybe it's something a little more convoluted. Six two seven three. Seven is created by 1, 2, and 4. One XOR 6 would give you 7. Maybe that's what we're actually supposed to do. This works, but I don't get it. I don't understand. I guess subtraction, XOR is similar to subtraction in a really, really weird way, because you can't use the same bits. So in a weird way, it is subtraction, but not really. What was this question really asking? Is it just saying that XOR is commutative? For example, 1 XOR 0 gives you 1. But if you do 1 XOR 0, you get 1. Similarly, if you have 4 XOR 6, you get 6. I mean, if you do 4 XOR, wait. Yeah, if you do 4 XOR 2, you get 6. But if you do 6 XOR 2, you get 4. So maybe it's just saying you can go either way, forwards and backwards, which is actually really interesting. Which is why it seemed like subtraction in the beginning, but it wasn't, because XOR can sort of simulate subtraction, but not really. Interesting. I think this person has A XOR B equals C, A XOR B. Yeah, you can get A or B back if you have the other value available. I wondered if it was equation based, like they just solved it, but I don't really know what the opposite of XOR is. I think that's the issue here. I think that's what they're saying, the inverse of XOR, which is what you would do when you're trying to solve an equation. For example, if you had A XOR B equals C, you move it to the other side by doing XOR the value, which is actually really interesting. At least I think so. That was a cool problem though. So we have monotonic array. An array is monotonic if it is either monotone increasing or monotone decreasing. Can you have values that stay the same? No, I think you always have to be increasing or decreasing. An array nums is monotone increasing if for all I is less than or equal to j, num sub I is less than or equal to j, so they can be the same, or they can have values that don't change. An array nums is monotone decreasing if for all I is less than or equal to j, nums sub I is greater than or equal to nums sub j. Given an integer array nums, return true if the given array is monotonic or false otherwise. Interesting. So I think we could do this in linear time. We're not given a sorted array, so you. Oh, I mean, yeah, we're not supposed to sort the array. I guess we can just check in linear time. If we go forward through, right? If we go forward through and it's only increasing, we can set a value like is increasing to true. Or I guess, yeah, we can return true. Then we can check in reverse to see if it, oh no, you would just check, yeah, I is less than j, so they want us to check both ways. So you get false for is increasing for this one, but you get true for is decreasing, and you get false for is decreasing here, but true for is increasing. And for this one, you would just fail. So at the end, we can just return false, and we can just say for that I, put a 0, I is less than num stuff length, I plus plus. So if we'll go one element less, say if num sub I is greater than or equal to num sub I plus 1, I see this makes it's still a simple problem, but it's just a little tricky because you don't want to exit too early. So instead we'll do it like this. I mean, we could just return increasing or decreasing, then it's monotonic. So we'll say if num sub I is ever greater than or equal to num sub I, then what we'll do is we'll say increasing equals false. And then we can duplicate this one, do the same thing, except change this to less than or equal to the decreasing equals false. I mean, yeah, that means we have to start them at true. So if they ever break the rules, set them to false, and if it's either increasing or decreasing, we'll return that. So increasing is equal to true. 1 is less than or equal to 2. 2 is greater than or 1 is greater than or equal to 2, so we're good. 1 is not greater than or equal to 2. 2 is not. Actually, yeah, I want to remove the equals now that I'm realizing it. Is I great? No. Is, because if they're the same, then it's also fine. We only want to check the error case. So if 1 is greater than 2, we set it to false. Is 2 greater than 2? No. Is 2 greater than 3? No. So it is increasing. Then we'd say, okay, is 1 less than 2? It is, so it's not decreasing. I feel like there's a more elegant way to write this though. I feel like there's going to be an XOR solution here. Yeah, this is what I was thinking for a single pass. You can just combine them. So given two arrays R1 and R2, elements of R2 are distinct, and all elements in R2 are also in R1. Given two arrays R1 and R2, the elements of R2 are distinct and all elements in R2 are also in R1. That could be confusing. Sort the elements of R1 such that the relative ordering of items in R1 are the same as in R2. Elements that do not appear in R2 should be placed at the end of R1 in ascending order. So we're given R1 and all the elements in R2 are also in R1. So we have 2, 1, 4, 3, 9, 6. So 19, 7. Yeah, 19 and 7 should be placed at the end of R1 in ascending order. Okay, we want to just sort the elements of R1 such that the relative ordering of items in R1 are the same as in R2. Sort the elements of R1 such that the relative ordering of items in R1 are the same as in R2. So we have all the 2's, then we have 1, 4, all the 3's, the 9, the 6, and the 7. So we could have end equal to an empty array of numbers. What we'll do is we can create a new set from R2's numbers. From here we can iterate through R1 and the elements that are going to add to end are going to be as follows. So if R2 nums, right, has R2 nums, right, we also need something else, R1. And the goal here basically, since if R2 doesn't have the number at R1 sub I, if R2 doesn't have the number at R1 sub I, it means it's part of the set that should be included at the end in ascending order. So we can say end.push R1 sub I. That will save for later. If it does exist, we want to add it to this map, which we'll use to reconstruct the array. And I guess we could also sort the relative elements of R1 such that the relative ordering of items in R1 are the same as the items in R2. So we could load these. I'm getting a little confused. We can load these into a map, and then for all the elements in R1, we can just reconstruct the elements in this general order. When we're finished, we can add the elements at the end of and sorted to the output array. All right, so I think that works. And I think R2 nums, which will have the relative ordering of the elements in R2, should retain the order in which the elements were inserted into the set. So we'll say constant value is equal to R1 map dot has R1 sub I. Then we want to get. We almost have no need for this index. R1.has num, right? Then we want to R1 map, get the number of occurrences for that number, otherwise we'll set it equal to 0, and then we can say R1 map dot set num equal to value plus 1. From here we have to create the output array by first sorting and in ascending order, and then the output array will be created here, where we'll go over for const key of, it was called R2 nums, right? Then we'll do for at I equals 0, right? I is less than R elements that do not appear in R2 right. So we'll say R1 map dot get key I plus plus. We can say output dot push key. And we can return output dot concat. And not exactly convinced that this works though. So we have end array, which is, and we have R2 nums, which is a set of the numbers created from R2. We should just call this R2 set, which is very confusing, which is probably why this whole thing is hard to reason about. R2 set has the number, so if R2 has the number in R1, or if it doesn't have it, right, we push it onto end, because they say here elements that do not appear in R2 should be placed at the end of R in ascending order. So we'll push it onto the end. Otherwise we save it into a map where we map numbers to occurrences. We sort the end in ascending order. Then for each key of the R2 set, we then create the output array based on the occurrences of R1. Something about this problem is very confusing. So R1 all elements in R2 are distinct, and all elements in R2 are also in R1. So considering that, let's just say R1 is arbitrarily long and only one element of R2 exists, which would also exist in R1, the sort could take n log n time plus n plus m, with I guess n space. For an n R2, counts of n minus. I have no idea what this person is doing here. Oh, is there a follow-up? There is no follow-up. This is clever because the array is technically pre-sorted. So that is pretty clever. It's like an optimized version of what we did. We sorted the end, but if they used all the counters, we could apply the same optimizations when we work here. When we do output.push key, we can subtract occurrence from our toSet. And then the issue being that the order the keys are in are not exactly sorted in ascending order, which is why they used the array in the first place. That's pretty clever. So I guess that's how counting's sorted. It's something to do with using an array to bound all the values, and the index is actually the number, and the number at the index is the number of occurrences. So that is pretty cool. Check if two string arrays are equivalent. Given two string arrays, word 1 and word 2 return true if the two arrays represent the same string, and false otherwise. A string is represented by an array if the array elements concatenated in order forms the string. I think we could just check if word1.join equals word2.join. But maybe they don't want us to use anything like that. So let's try an actual version where we have to think about how to pass the index over. What we could do with the space required for both of them is to pretty much flatten the array. Flatten this array of strings of different lengths into an array of characters by just iterating through every element in the string, every string in the array, and then every letter in the word, and push that onto an array. That'll be n plus m time, n plus n space. And then we can return false. Oh man, I forgot to do I is less than r dot length. I wonder if there's a way to do constant space. Seems like it would be a useful trick for the future. Why is it n times k? not following. If you loaded both arrays into, if you loaded both strings into a new array, Yeah, I think like we said earlier, the better way would be to use a string pointer version with constant time. But I actually don't know if we said that. We only have 47 seconds left. I think we can just have count equals 0. I think this would fail in the case where the strings are not the same length. For example, if we had something like B, right, and bank, this would return true. So I think the other thing we should say is s1.length equals s2.length. I wanted a different solution than actually, I guess it would be the same if we swapped both of the letters and then just checked if the strings were exactly the same. But if we say they don't match, actually it doesn't matter, right? Actually it does matter. Do we also always know which string is the... I think we can work this one out, but I think that's a good place to stop for today.